Hello everyone, welcome to the past paper discussion. We are in 7th question, that is the last part of the series. It is a vectors based question. Let's get started. Right, and this also carries 20 marks. Let's break this down by steps. First, a position vector of a particle at time t is given by its position vector. Right, so R vector represent position of a particle when time when time is t. And displacement is measured in meters and time is measured in seconds. So this is actually R. Right now, first and foremost, we need to find velocity expression for the particle at time t. So velocity is just position vector means it's displacement, right? So you have to just differentiate it. So dr by dt will give you velocity vector, right? So very simple differentiation. We have this differentiation rule in our booklet. So let's get started. So here cos x, when you differentiate, it is minus sine x. But I have here 3t, right? So chain rule you need to apply. So how will you apply chain rule? So 3 is a constant, let it be as it is, times cos 3t, when you differentiate, it is minus sine 3t. We know that. Then the chain rule says, if it's just x, this will apply. If it's 3x, you just differentiate this and multiply. So 3t, when you differentiate, it's 3 and you need to multiply. That's what the chain rule states. Correct? So we did that and that's it. I vector. Plus the next part, same. 4 is a constant, keep as it is. Sine 3t, like for example, sine x, when you differentiate, it's cos x. But sine 3t, when you differentiate, cos 3t, then you multiply by 3. What is this 3? The differentiation of the input. Then j vector, right? And you can simplify for the simpleness. 3 times negative and here a 3. Totally minus 9. Sine 3t I vector plus 4 times 3 is 12 cos 3t j vector. That's simple. And you can use vector notation also, like minus 9 sine. This way also you can write the component form or linear form, both will work, right? That's simple. Now find the speed when t is 3. Okay, what is speed? Speed is nothing. Velocity, you know. So speed is just a magnitude of the velocity, right? So magnitude of velocity when t equal to 3. So how to find magnitude? This is also available in our formula booklet. Modulus of a vector is square root of their component, v1 square plus v2 square plus v3 square if you have 3D. But just we are dealing with 2D vectors here, right? So now modulus of v is equal to, what is my vector? Minus 9 3t. That's the first component, so square it. Minus 9 sine 3t whole square plus another component is 12 cos 3t square. 12 times cos 3t whole square, right? And then we can just move ahead by simplifying. Also, I'm not solving for t, right? When t is 3, particular value we are solving it. So this is our speed. We will go with minus 9 sine. When you substitute 3, 3 times t will become 9 whole square plus 12 cos 9 the whole square. That's simple. And rest we can do it with the calculator. Now moving to the calculator page. You take a normal calculator and plug in the thing. So we need to give square root of, yeah. So I got it. Minus 9 times sine 9 the whole square. Then out of that plus again a square. Inside the square it is 12 cos 9. 12 times cos 9. Okay, that's it. We got 11.45456. So we can just approximate it. Moving to the solution page. Okay, so the speed is 11.5 meters second per minus 1. That's the speed. Right? Now, next part is the position vector of a particle time t, so which is what they have given, or, and we need to find an expression for acceleration of the particle t at time t. So like just an expression they want, correct? So acceleration is, we know acceleration is derivative of t, derivative of v. V is derivative of position, that is displacement, yes. So I already know the v, correct? Where it is. So this v or this v, you can take anything. Let me take the first one. And let's differentiate it. Or it, yeah. So let's go. And dv by dt will give you acceleration vector. Right. So it's the same formula. Sine ax, if you want to differentiate, it will go cos ax times a. So here instead of a, I have 3. Instead of x, I have 2. That is t. So minus 9, you will keep as it is. Sine 3t when you differentiate, cos 3t times the 3. Whichever here will multiply. And that's it, I vector. Plus 12, similar way, keep the 12 as it is. Cos 3t when you differentiate, minus sine 3t times 3. We have j vector here. So it's minus 9 and 3 is minus 27. Cos 3t I vector minus 36 sine 3t j vector. That's it. So this is what our acceleration in terms of time t. Right? That's simple. And moving forward. Acceleration always directed towards the origin. This is what we need to prove. Actual context is hence show that. So using that. So here is very important. If they give hence or otherwise, you can just use another method also. But if they give hence, use the previous one. Use this acceleration stuff and try to prove that always directed towards origin. Okay, let me use this one. And there is a little concept behind this. We can just quickly recall that before solving. So when the acceleration, so one vector will be directed towards the origin and it is always means. So yeah, we have a general expression. And when acceleration vector is proportional to negative of the position vector. So acceleration vector should be proportion to negative of position vector means r vector. If we can prove this, this means for that is acceleration is always directed towards the origin. Correct? That is we will see why how it is towards origin, but this is the condition, right? So try to express. Okay, so this is in proportion. So a vector equal to some negative value of something, negative and times k into r vector. This is what I need to prove. Yeah, let's take the common thing outside. So here I can take a negative and a 9. We can express like this, and this is negative 9 times 4. So a vector will become negative 9, 3 cos 3t I vector plus 4 sine 3t j vector. This is nothing but my r position vector. Let's go and quickly check what is my position vector. 3 cos 3t, 4 sine 3t. Same thing I got. Everything is as it is. with a minus sign multiply. So yes, I can prove that acceleration is uh, a negative multiple of position vector. So this implies A vector, the negative implies A is opposite to R. Correct? Acceleration is opposite to the position of the particle. Now, what is R? R is a position vector from the origin, right? So position vector means this is your point and this is how it will go. So R is position vector from origin. So like it's moving away from origin. So if it's another vector, which is A vector is negative multiple of this R, means it will move inwards the origin. Correct? So this implies A vector is always, we don't have any conditions applied here. It's just to hold for every value of t. So always directed towards the origin. Towards. So this goes like this. This will come like this. Towards origin. Right. And that's simple. We have proved this part. Right. And moving to the next part. So this is for the first particle we discussed and we dealt with a lot of things. Now, the position vector of a second particle is given by this equation, vector equation, like vector form. Minus 4 sine 40i plus 3 cos 40g. Now, the question is, for 0 less than t less than 0 less than or equal to t less than or equal to 10. That is from time 0 to 10, two particles are closest to each other. In this particular place, what is that moment we need to find? Okay. So at time k, where k is 0 less than or equal to x less than or equal to 1.5, the second particle is moving parallel to the first particle. This is one more. Right. So for this, two particles are closest to find the time when two particles are closest to each other. So let's solve this one. Yeah, I need to compare the two particles. So I just took the position vector. Why here position vector is taken? Here the question is find the time when the two particles are closest to each other, like not moving, right? So particles are closest to each other. They are trying to convey the position, right? So position vector should be taken. So take R1 and R2. R1 is the original one that we have solved. This I have taken as R2, second particle. Okay, closest means what? The distance between two should be the minimum, right? So yeah, I can find the distance formula between them. So D equal to modulus of R2 vector minus R1 vector, which is equal to, it's quite simple. Just R2 vector for the x component, you just subtract this. So I will get minus 4. Like it's very simple. X2 minus x1 the whole square plus y2 minus y1 the whole square. Same form. So vector components, I'm going to subtract. Subtract the x components, minus 4 sine 4t minus 3 cos 3t whole square. Then plus y2 minus y1. 3 cos 4t minus 4 sine 3t the whole square. Actually, this should be whole under the root. Hope you get it. Right. So I want the minimum distance. Now you know distance function of the closest, that is the distance function between the two particles position. And you want to minimize this. So simply we can go for the graph this entire distance function, and then we will make it analyze graph and we will find the minimum point. That's simple. We will get the time from that. Got it? And moving to the calculator part. Okay, so let's go with graph. Right. Graph entry, we are going to give a function. This function is square root of, there are two squares involved. So first is minus 4 times sine 4x. So there we are using t. Here we need to change in that way. Hope you can follow it. 3 times cos 3x. the whole square. Then plus, again you need to square 3 times cos 4t, that is here 4x, then minus 4 times sine 3x. Okay, we have given all these stuff. Right, so check that and we can just click enter. We got a beautiful graph over here. And I'm gonna work this graph. Okay, so this is a distance and time over the time. Right, and we need to do it from 0 to 10. What is the minimum? So let me go for this window setting. X is from 0 to 10. Right. So now you need to find the minimum value. Go for analyze graph. Go for minimum. Upper bound is pivot. Okay. So go for analyze graph. Minimum. Lower bound is 0. Upper bound is 10. So it shows the minimum. 4.71239, 1. This is the minimum value, right? So that is your value of t, 4.71, right? That's simple. And moving to the t. So from the graph, we got t is equal to 4.71 seconds. Okay, what is this t? This is the time where the particles are closest to each other. Two particles are closest to each other, right? And next, at time k, where k is between 0 to 1.5, 0 and 1.5 are excluded, we need to find the second particle is moving parallel to the first particle. Okay, either in this way or this way, something they are moving parallel. Find the value of k in this case. And then one more part is there. At time k, show that the particles are moving in the opposite direction. First, let's focus on value of k. Here we should note one thing. The second particle is moving parallel to the first particle. So I should not use the R1 and R2. This is not useful. I need to use velocity 1 and velocity 2 because this case particles are moving and when they are moving parallelly, like not the positions here, right? So R2 parallel. Okay, let's find V1. They are parallel. So how to find V1? Differentiate. This we already have. For the first thing, we calculate chill acceleration. So I'm going to copy that. This is my V. Where is my V? So here it is. You can take this or you can take this. Yeah, let's take this one. This is my V1. For the particle one, it's already done. So you can just use that. Okay, V2, we need to form it. Okay, so for V2, just differentiate it. Minus 4, copy as it is. Sine 40, when you differentiate, it will become cos 40. Then this 40, right? I will multiply that. Then I cap. So this one will be 3 times cos 40 when you differentiate minus sine 40. Then I should differentiate that 40 part, which is 4, j vector. So this is V1 and V2 is, let me simplify, minus 16 cos 40 I vector minus 12. Wait a moment. Okay. Minus 3, 4 and minus 12 sine 40 j vector. So we got V1 and V2. Now we need to use this parallel condition. They are moving parallel. So we find the velocity functions, velocity expression for the two particles, right? So what is the condition? Either we can say the slopes are same, or V1 is a scalar multiple of V2, we can prove. So I'm going to prove it using the slopes. How will you find slope of M1? That is a vector 1, slope, let it be M1. It's very simple, Y2 minus Y1 by X2 minus X1. Right? So we will get right, and the slopes will be same. So it is from the origin. So we can just take 12 for the first one, y2 minus y1. So it will be just 12 cos 3t minus, what is y2? Actually, it's 0, right? So that in that case, divided by x2 minus x1, which is minus 9 sine 3t, and x2 will be 0. Similarly, m2 for this one, y2 minus a1. So like just we can minus 12 sine 40 by minus 16 cos 40 and simplify it. Okay, they should be equal, right? Also, I can make like m1 minus m2 equals 0. Right? M1 is, or m2 minus m1 is 0. So I want to just subtract. Let me choose m2 minus m1, which is better for me. So m2 is like positive. So that's why I choose it first. 12 sine 40 by 16 cos 40 minus m1 is already have a minus, so it will become plus 12 cos 3t by 9 sine 3t equals 0. Okay. So what we are solving, in 0 to 1.5, there is a timestamp I need to find. So k is nothing but a time, right? So you solve for time for this equation, and then you will get it, and you just convert it to k, right? And better we can, yeah, graph this and find it. Let's switch to the graphing calculator. Here we go. Let's go for another graph. Okay, I got this fractional form. So go for fraction. 12 sine 40 okay, that t here x divided by 16 times cos 4x plus again a fraction 12 times cos 3x 9 times sine 3x. That's it. This is a function I have. When we graph this, we got this kind of scenario, and I'm going to look for the timestamp between 0 to 1.5 they have given, right? So let's make the window settings as 0 to 1.5, and also the 0 and 1.5 are not included. So this is what I got. Now, this should be 0. I got this function equated as 0. So I need to solve for x. So x-intercept. That is, go for analyze graph and 0 of the graph. And clearly I can see there is from 0 to 1.5. Here is what the 0 is formed. And even you can give over here. So 1.30135 I got. Right? So that's it. Now this is my k value. This time is my required k value, and we can just interpret here. From GDC solving, we got this t equal 1.30. Okay, t might have so many values, so it's better to say we solved in that timestamp, right? So k is equal to 1.30 seconds. That's it. At this time, the two particles are moving parallel. Right. And next part. At this time k, show that particles move in opposite direction. Okay, the time I know and velocity we already found. I just copied that. To prove the vectors are moving in opposite, we have to prove v1 is equal to negative scalar multiple of v2 or v2 equal to 1. Either way you can take, but I took in this way. Correct? So what is my v1? And in this case, it's better to write like minus sign in the component form. Minus 9 sin 3t, 12 cos 3t equal. Let it be L. I'm going to just prove L is negative. Okay, this is just to say it's a negative multiple. L times minus 16 cos 40 minus 12 sin 40. Okay. Right. Now, what is time? At this time k, they have mentioned. At this time k. This is mentioned. So k is 1.30, I know. So you just substitute minus 9 sin 3 times 1.30, 12 cos 3 times 1.30. So vectors are becoming the known numbers, like the variables. 16 minus 16 times cos 4 times 1.30 minus 12 times sine 4 times 1.30. Okay, I just need L now. L should be negative. If I prove it, then it implies that they move in opposite direction. So take any one of the part. The vectors are equal. So minus 9 sine 3 times 1.3, 3.9 equal minus 16L cos 4 times 1.3. It's around, yeah, you can use calculator. But here we got 4 3s are 5.2. Okay, what is my L? Negative, negative cancelled. My L is going to be sine 3.9 by cos 5.2. Okay, so sine 9 times, that will also include, and 60. Let me evaluate. It should be a negative. So I'll switch to the calculator and do this. We hope for a negative value. Take a normal calculator. And we have fraction value to be. So 9 times sine 3.9 divided by 16 times cos 5.2. This is my L. I got a negative 0.82573. Right? So that's it. Yes, I am looking for negative, which implies they will move in opposite direction. So my L is negative 0.82 approximately. So what I have proved, V1 is equal to negative 0.82 times V2. So this means they are moving parallel in opposite direction. That's what it implies. So yeah, the proof is done. And that's a little big question, but it's just all that simple concept. Right. So that's it for this video. We can meet in the next series. Until then, keep learning.